this session, we will discuss about different tools, strategies, platforms for data science and analytics. One of the key areas nowadays in every domain, not only in engineering, whether you are from humanities, commerce, or applied or pure sciences, in every segment we are having enormous data. So how to evaluate that particular data, how to find out intelligence from that particular data, that we will cover in this particular session. First of all, we will see if our work is related to data science and analytics, then which are benchmark sources of data sets, whether we are working in academic research, corporate, or social research. Many times, research scholars, practitioners work on data analytics and they try to implement some algorithm on a particular data set related to a domain. So, in whether we are working in data science or artificial intelligence, machine learning, deep learning, in all of these segments, we need data, pre-processed data, fine-tuned and accurate data. So first of all, we will see different sources of data sets from where we can get very accurate data for our research work or for teaching also. IEEE data port. For example, we are working in sentiment data analysis, natural language processing, or as in previous session, we have discussed about computer vision, speech recognition. All of these segments are having base of very fine-tuned data. If we are in research domain, then we have to use benchmark data sets for our research. So many links available, sources available for benchmark data sets. For example, we are working on X-ray data analysis, EEG data analysis, ECG data analysis to find out some disease in patients. If we need some data related to criminal behavior, we want to predict a set of persons, how much probability is there that they are involved in some criminal activities or they are having some criminal aptitude. First of all, we should be having huge data related to that particular domain. So at first instance, we have to take huge data set about that particular research domain. So you can see here, in whatever segment you are working, in whatever domain you are working, data sets are available. Astronomy, artificial intelligence, computer vision, COVID-19. You might have seen huge work is going on in this particular segment, COVID-19. Demographic, power and energy, spatial data sets, wireless networks. If we take example of data analysis related to malware in a particular organization, in your institutes also, you might be using hotspots, Wi-Fi hotspots, and if our work is related to finding out probability of malware or malicious traffic in your Wi-Fi hotspots, by which way we can do it? First of all, we should be having data sets from those sources which provide malicious fingerprints of data with malicious key points, and then we can train a model. So data science and artificial intelligence, these are interrelated. When we work in data science, generally in most of the times it is associated with artificial intelligence, because we have to train a model with a fine-tuned data set. So you can see here, this is IEEE data port, and all of these data sets are completely free in whatever domain you are working. So you can see, if your domain is related to some particular tweets, what people are discussing about this disease, what people are discussing about this particular variant or upcoming variants of this infection. So Twitter data set related to COVID, Facebook data set, or panic related data sets. All of these are available. Along with this, you can explore UCI machine learning repository, another source of benchmark data sets, because in research, in academic research, we have to take benchmark data set for our implementations. Okay. So you can see heart disease data set. Okay. So data science, data analytics, artificial intelligence, its segments, these are interrelated. We can't say that data science is a separate domain from artificial intelligence. When we are having a huge data set about some particular disease, our major motive is to find out hidden patterns, associations, dependencies, and these associations, dependencies, integrations are identified using AI based techniques. Okay, so as in previous session we have covered about AI part, now we will see with AI how to use a fine tuned data with some particular libraries and platforms which are easy to use. Okay, so heart disease data, so many data sets available. Okay, so along with that, Kaggle data sets available if you are working on computer vision or some other segment. As far as benchmark data sets are concerned, generally these data sets do not require cleaning, because these are already tested by different researchers. Okay, so here you can see, for example, we need some data set related to loan or credit cards. It will be available. We want to find out the default rate prediction, fraud prediction, fraud detection, credit card fraud transactions, or probability of that scenario. So you can see MasterCard stock data, stock market data. These are already available. We have to fetch it, and then we train these data sets in our machine learning or artificial intelligence based models. Okay, so all of these links I have given in this presentation, which you can explore. NCBI portal, very popular portal. NCBI portal, very prominent platform if you are working in biomedical or pharmacy based research, data analytics on pharmacy. So in previous session we have covered med rxiv, bio rxiv. Okay, so in parallel to that we can use NCBI portal, National Library of Medicine. It is having so many data sets related to protein structure. If your work is related to biomedical engineering, if you are working on some DNA or some protein structure based research work. Nowadays we are in the era of multidisciplinary or interdisciplinary research. You might have seen that in many universities, on almost in every university, there are research topics or implementation topics which are interdisciplinary. Researchers from mechanical engineering, they are working on robotics. Researchers from civil engineering, they are they are processing their data using artificial intelligence. Researchers from computer science and electronics, they are taking biomedical data, X-ray, MRI. So interdisciplinary. And what is major benefit of this particular task, this implementation? To elevate, to expand our scope of publication, to expand our scope of demonstration. You might have seen, as all of you are academicians, you are renowned professors in different organizations, and generally we struggle for very good publications, SCI, Scopus. And if we focus only on our own domain, for example, in engineering only, there is a huge crowd of papers, huge crowd of manuscripts. For example, somebody is working on IoT, publication or journal is also on IoT. Still, it takes 1 year, 2 years in getting good publication because of the focused, very pinpoint work. Okay, in case of multidisciplinary research, interdisciplinary or integrated research, for example, some researcher from computer science or electronics, technique is artificial intelligence, but data is related to satellite, or data set is related to biomedical images. In that case, scope of publication will be expanded in medical journals also, in pharmacy journals also, in NASA, DRDO journals also. That's why nowadays experts from multiple disciplines are coming together. They are joining hands so that from each and everybody's expertise, some particular significant work can be presented. So that's why we are covering this point, data sets, NCBI, and you can see, for example, you are working on artificial intelligence, data science, and analytics. Rather than taking traditional data set, we can take data sets related to ECG, EEG, MRI data, CT scan data. So MRI data, you can see knee MRI data available in DCM format, CT scan data, DCN DICOM images. Okay, technique will be same, data science will be same, artificial intelligence, machine learning, everything will be same, but major thing is that data set will be related to some other domains, and it is very easy and almost same which we process in our classical domains. So we should not worry about that. If we are having CT scan data in DCM format, so you can see that if you are having DCM file, then how to process it? This is the software micro DICOM for processing of DICOM images. DICOM images means if you are having medical data in 3D format. Okay, so DICOM viewer, all of these are available in free distribution. Micro DICOM, if our work is related to processing of data related to CT scan, MRI, or DICOM images, ECG data, EEG data. Okay, so you can download these packages in free distribution. Okay, there are lots of packages which we can use for processing of these data sets. Okay, so you can see that this is DICOM format, digital imaging and communication in medicine. How to process this particular data? So we are working on this software. Very soon we will see it by which way process it. Micro DICOM, medical data, very complex data. How to process it? Okay, so first of all, I will show you some sources. Okay, so some images I have already downloaded. So from this portal, you can see that these are the images, DCM images related to particular disease in DICOM format. Okay, now if I want to implement data science technique or artificial intelligence based technique on this particular data, then by which way we can process it? So this is DCM file. So if I will open it in Notepad plus plus or in Notepad, it is not understandable. Okay, everybody knows that we can't apply machine learning or deep learning on this particular data. Okay, if I want to train this data in AI model or in data science model, if it is related to CT scan, it is not possible. How to process this data? How to read this data? What this data want to say? What this data need to highlight about a particular disease? So for that, we can use data science based software. You can see that now this DCM file is opened here in this panel. This is DCM viewer. Now how much it is easy to process it? For example, this is a tumor. I want to see, okay, what is the size of this particular tumor? So simply you can see that I am dragging it, and Medical images, medical data in 3D format can be processed very easily. What about mean, standard deviation, area? For example, up we are having a particular MRI or CT scan or X-ray of a particular human organ. We want to see size of that stone, dimension of that particular disease, or association. You might have seen association is also integrated, is also identified. Okay, if there is some tumor in brain, if there is some tumor in kidney or wherever it is, from where it is originated, that can be identified, that can be evaluated using data science based software related to medical and pharmacy. So file, okay, export. In which format we want to export it? In text format, everybody knows that it is not understandable in this format, but we can export it in understandable format in text file. Okay, and once it is exported to text file, then we can do anything with that. In same way, for example, we want to see this particular area, and at right hand side you can see different parameters are also given, at which date and time this reading was taken. Export to picture file, in which if we want to export it in JPG format, we can export it, because many times researchers need JPG or TIFF format. File name prefix, any name, for example MRI export, and now you can see that it is exported to this format. So how much it is easy? Is this visible to all of you? Is it visible and clear to all of you how to use very effective software for medical data analysis under the segment of data science? Okay, so
Excuse me, sir. Can you tell me the name of this software again, sir?
sir,
Uh,
this is microdicom. I will share this presentation at end of the session also.
okay, okay, okay. Thanks. Sir. One more thing, sir. How can you read that TIFF file data, TIFF?
TIFF. Okay.
Yes, sir.
To process to read TIFF file, generally we use Python language.
Okay,
In
sir.
Python also we can use. I will show you one demonstration of Python to read this DICOM file also. Okay. So for TIFF also we can use generic programming language is Python, but lots of other software available which we can use for data analytics part. Okay, so this is one thing, this is one implementation we have seen, that how to process a particular medical image that is in 3D format, because DICOM images or DICOM file that is in multi-dimensional format in multiple orientations, we process it. Okay, so this is the file. Now if I want to process it using Python, okay, without using any software, without using any third party software, if you want to use it, if you want to process it using Python, then we have to use this package in Python language, pydicom. Okay, so simply what we do, simply pip install pydicom. So I will not press enter because pydicom is already installed in this system. Okay, if because when you install Anaconda or any other Python platform, then by default we are not having this package. Python is a package based programming language, and whatever utility we want to use, we can install it explicitly by pip installer. Okay, and after installation of pip based PyDicom, we will be able to use it. So you can see that import PyDicom, which file name we want to process, DCM file. This is DICOM file, and now we can run it with this name. And now you can see that how much it is easy. So it has extracted the complete metadata and internal details of that image. So it is visible here that it is a CT scan image, CT image storage. And what about study time? What about manufacturer? Okay, and in which format it is available. Okay. Otherwise, if we will read this file in this way, it is not readable. It is in binary format. Okay. We can't process this data in any tool. We can't process this data in machine learning. Okay. To process this DCM data, we have to be sure that it should be in text format. Okay. Now, in text format, we have exported it, and we are able to evaluate any other image also. We can take, for example, this is I4. Okay, any now d4 d3.dcm. Okay, now d3.dcm file. On this file we want to use same implementation. Okay, its file is d3.dcm. Now I want to study, we want to find out internal details about this particular DCM file. We can find out. Okay, so this is a complete folder from where we can extract different images. Okay, so you can see this. This is the portal pcir.org. So this is one segment related to DICOM images. There is another segment related to data science and analytics. So first of all, we will see which are different features of DICOM images. So you can see that it works as communication protocol as well as file format, and in multiple formats, in multiple image formats, data is embedded: PNG, JPG, medical information. We can put it like MRI, ultrasound, full encrypted, fully secured in multiple devices. We can place it. Okay, so these links I have put in this presentation so that you can explore how to work on this particular tool. Okay. Now we will see another data set that is related to biomedical images, that is known as PhysioNet. Very popular source of medical data. If our work is related to brain waves, if our work is related to brain waves, okay, so we are opening it. As far as ECG is concerned, that is related to heart waves or heart signals. If we want to work on data processing, data analytics related to human brain, you might have seen in criminal forensics, there are some specific tests like lie detector test, brain fingerprinting test, brain mapping test. Law enforcement agencies use these tests for identification of criminals, for shortlisting of suspects. So these data files are available in EDF file format. You can see that. For example, we are working on some data analytics part related to those patients suffering from sleep disorders, night walking disorders. So sleep based disorders, epilepsy, or some fits. These data sets are not available in text formats. If we are working on some data set, data analytics related to criminals, their behavior, criminal behavior, biometric behavior, such data sets are not available in classical text format. All of these file formats are available in form of EDF. EDF is European data format. So you can see that every file is having EDF extension. Any of these file we can download. Okay, just for demonstration, I'm downloading one file just to show you. So this file we have downloaded, this is EDF file, and I'm opening it in Notepad. Okay, in Notepad++, we have opened it. Now you can see that this is EDF file format. This is EDF file related to signals of human brain. Now, if I want to perform standard deviation or frequency analysis or simply summation, it is not possible on this particular data because it is in non-understandable binary format. If we want to use machine learning or deep learning, in that case also this data set is not fit. To make this data fit for our work, we have to process it. We have to analyze it using some tool. Okay, so you can see that as this particular data is related to human brain, so different brain points are given. C1, C4, so T7. So I'm showing you that part. In every human brain, there are different points. Okay, there are different points. Which are those? F7, T7. Images in Google Images, you can see. So you can see that this is the human skull. You might have seen when some brain fingerprinting is done, when some lie detector test is done, then some headphones, some sensors are placed on human brain, and data is captured from these points. Okay, which information is stored in this point in criminal's brain, which information is stored at this point TP7, which information is stored at this point PO3. So lie detector test or brain fingerprinting test identify each and every data from different brain points. and these are captured here, you can see. Okay, so in this, okay, but it is in binary format. We want to see, we want to convert it in numeric or some particular mathematical value. To work on that particular part for data analysis, for data evaluation on brain waves, we use physionet software, physionet based software, that is your EEG reader. EDF plus, EDF plus, Polyman, Polyman, completely free to evaluate, to process European data format. If we are having data related to human brain or body signals, we use this particular data for transformation in text format or Excel format. Because if we want to work on machine learning or data science, data should be available in Excel format, in Excel sheet, or it should be in plain image format. Even in MRI, in CT scan, in satellite data also, many times we get EDF files. So for that, we can download and install EDF plus software, Polyman, completely free. And that particular data, whether it is related to satellite or it is related to MRI, CT scan, ECG, EEG, or blood samples, it can be processed, it can be analyzed in this format. So very easily we will be able to view it in analog as well as numeric format. Okay, so this software I have already installed. So this link, this presentation I will share to all of you so that you can explore it. Okay, so this is the software. So if this software is installed, then automatically your EDF file will open in that EDF software for data analytics, and you can see that which points we want to extract. So different brain points are given here. You can see which points we want to plot, all, add to time window. Now you can see that this complete data set is available here. This complete medical data or that brainwave data available here, which we can process. Now if we want to use data cleaning, if we want to process this data in numeric format, you can see export active time window signals to ASCII, all files, all signals. Where we want to store, on desktop, save, export. So you can see that in few clicks we will be able to transform this data in numeric format. It is currently in waveform format, and now you can see that it is converted to numeric format. So this is actual EDF, and after conversion to numeric, it is in this format. Now, once we are having data in this particular format, numeric values, mathematical values, any machine learning, deep learning, or data science implementation can be performed. Otherwise, on this data, we can't do anything. On this particular data, there is no feature point. We can't find out some particular patterns. We can't implement any mathematical operation. But after converting this data to numeric format, we can train it in AI based models. We can use statistical methods. We can use data mining or any other approach. Okay, so very first part in artificial intelligence or machine learning is to make the data appropriate, to work on data science and analytics. Doctors also perform same thing. Before prediction on any X-ray or MRI, first of all, they verify whether their data is accurate or not, whether their machine is accurate or not, whether their software or hardware which is capturing that information, it is giving accurate results or not. That is the major part. After that, you can do anything. But if data is corrupt, if data is not accurate, then there will be compromise in everything. Okay, so after taking such data sets, we can train our model, we can work on any particular part. Okay, so this was related to the data science, data analytics, data processing related to medical images, medical data sets, MRI, CT scan, DCM. Okay, so these links I will share to you. So DICOM to JPG, many times we have to process, we have to convert our data from DICOM to JPG format. So for that, we can use this package DICOM to JPG. BioPython is also available. So it depends on that scenario, what we want to use for which implementation, DICOM to JPG. So these are very high dimensional data sets which are required in real world scenarios. If data is related to this particular domain, CT scan, MRI, CXR, and we have to process it. So DICOM to JPG, DCM to JPG, we can use. Up to this point, is it clear to all of you? Processing of medical data. Kindly write in chat to find out inherent details from such high dimensional data sets. Now we will see some other platforms which are related to real world data set processing and analytics of data set related to real time streaming channels, analysis of broadcasting channels. Data is related to social media, biological networks, social networks, Facebook, Twitter. Then how to process that particular data set. GAFI, free and open source, completely free and open source tool for data analytics. If if you are working on sentiment mining, emotions analysis, if your work is related to streaming channels, Instagram, WhatsApp, network, and we want to process that particular data, then we can use this software under free and open source distribution, that is GAFI. You might have seen when some particular crime happens, the law enforcement agencies tries to find out association between number of users. A knows B, B is friend of C, C knows F. What is relationship of A and F? A is friend of B, B is following D, D is friend of Z. Is there any relationship of Z and A? Such type of data analytics in criminal forensics is done by law enforcement agencies. At the time of peak lockdown, there was a term which was very, very common that time, that was containment zone, which are containment zone of this particular virus. Same thing can be processed, same analysis can be done via GAFI tool. Containment zone of a virus, containment zone of a particular infection in human body, containment zone, broadcasting zone of a computer virus. If we are working on a particular network, so okay, virus may be in human body, it may be in a computer network, it may be in a wireless network. So all of these are easily processable using GAFI tool. Social network analysis, link analysis. If you want to analyze a particular website to find out different broken links, different links having malicious traffic, malicious key points, we can extract it. In multiple programming platforms, Mac, Windows, Linux, plugins available, different plugins available. Okay, so you can see that so many plugins available. What we want to do, for example, graph markup language, click detector. If we want to see, for example, we are having a particular data set of WhatsApp messages, we want to find out root of a viral message. To finding out root of a viral video, who is the first person that shot this video or image and shared it. A is sharing to n number of people, n number of people are sharing to m number of people, but who is the first person? That is possible via GAFI platform for data analysis. So we will see it. This is GAFI tool. This software I have already installed. Okay, and you can see it is having enormous plugins. Whatever plugin we need, we can install it. Okay, so you can see that which plugin we want to work with. So Twitter streaming importer, if we want to fetch data from Instagram, from some other platform, it can be done. So graph streaming. Okay, so whatever processing or utility we need, its corresponding package or plugin to be installed. Okay, and if I want to fetch data from Twitter, for example, we want to analyze data from Twitter, what people are discussing about a particular topic. You might have seen at the time of elections, such type of implementations are done by political parties, what people are discussing about their election candidates on Twitter, what people are discussing about their party from their constituency. All data sets can be fetched from real-time streaming modes. So after installation of this plugin, you can see credentials. These are the credentials. We have to put these credentials in Twitter to fetch social media data. Without these credentials, we can't fetch anybody's data. If we need to fetch data from WhatsApp, from Instagram, we need tokens. Okay, so how to fetch these? There is a portal apps.twitter.com, apps.twitter.com or developer.twitter.com. This is the portal developer.twitter.com, or you can open apps.twitter.com. Account will be same, no need to create a new account. Keys and tokens. So from this particular platform we can generate keys and tokens, which we have to put here in whatever programming language you are working on data analytics, whether Java, C++, or Python, or any other programming language, or any other tool. Without these tokens, we can't fetch data from real-time social media. Okay, so after copying these tokens, we put it here. Simply copy and paste. These are encrypted tokens, and using these tokens, Twitter will come to know what we are doing with their data, whether we are using their data for research or for any other activity. With these tokens, social media platform will come to know. They ensure that these tokens should not be used for any anti-national activities. Okay, so we can specify. So its link is also given here, apps.twitter.com, same link. Okay, now what we want to extract, for example, we want to find out some, we want to extract all information from a hashtag, hash, any hashtag you can put, whatever hot topic is there today, popular hashtags. Okay, users to follow. We can fetch complete data from a particular timeline, from a particular user's Twitter handle. Location to follow, longitude, latitude. What people are discussing from a particular longitude, latitude about a particular topic. For example, government has released a notification, and there are some anti-national messages, there are some messages related to anti-incumbency. So government agencies can easily find out, okay, from which longitude and latitude people are discussing about this particular keyword or this particular news, in positive way or in negative way, in which languages people are discussing: Arabic, Bengali, Urdu, Hindi. In every language it can be extracted. Okay, so just for demonstration I have put some keywords and now connect. Now you can see that in middle this network is getting formed. So now I'm clicking on disconnect, otherwise lots of data will be collected. So you can see that this is the complete network of all of those people who are discussing about these two words in parallel, in real time. What people are discussing, we can put anything at the rate with Twitter handle, Twitter hashtag. So this is the network of all users about some particular keyword, some particular viral message. We can write a viral message hashtag also, which people are involved, which people are integrated in broadcasting this viral message, or which people are contributing to make this message as viral. We can put that keyword or URL of video, image, or hashtag. In between we will get this particular network. Now if you want to see shortest path, okay, A knows B, B knows C, C is friend of D, is there any relationship of A and D? So this is aeroplane symbol, shortest path. So on click of any two, so on mouse over of this you can see that it is related to this person. So all nodes will be highlighted. So data analytics, so this is under data analytics on social media, social platforms. If you want to see name of those people, name, profile, DP, their mobile, their platform, data laboratory, you can see data laboratory. We are able to see complete data in text format. This is tweet. Okay, whether it is a tweet or hashtag. Okay, so we can download this data, export table. On desktop we can export it, and now you will see this data. Okay, with anybody's, so you can see this is the complete details, all data we have extracted. We can see anybody's DP also. If I want to see this DP, who is this person? All details will be available here. So you can see this is the DP of that person who is sharing this message. If I want to see any suspect, any message which is suspicious, and I want to see its DP. So this, everybody's complete details is available here. This is known as analytics of social media data. Okay, okay. And which platforms they are using? Android. I want to see how many people are using Android phone. Okay, we can take how many followers are there, how many friends are there, in multiple languages, in Hindi, English, in multilingual format. It is available. So in same way, if you want to see this DP, if some suspect is there, so this. How much it is easy to extract and analyze social network data. On which hashtags they are discussing, on which hashtags they are mostly active, which type of emoticons they are sharing. So you can see that which hashtags they are promoting, which Twitter handles they are promoting a lot. Okay, so once it is extracted, so which attributes are there, you can see all of these attributes: description, email, profile, image, friends count, how many friends are there with that person, how many followers are there with that particular person, what is real name, from which location that person is sending message, emoji, email, profile, image, country, longitude, latitude. So we should be very cautious while covering some point on, while marking some point on social platforms, because everything is logged in, and you can see that whosoever is having these tokens, in same way we can extract data from Facebook. But if we want to extract data from Facebook or WhatsApp, we need permission from every account, because you might have gone through that recently in Constitution of India, right to privacy is added. Facebook, WhatsApp, these are private platforms. There are private chats. Okay, friends. As far as Twitter is concerned, it is not private. It is broadcasting platform. So in case of broadcasting platform, anybody can publish a particular data and it can be broadcasted to any number of users. Okay, so if you want to take data from some particular private channel, we need permission, otherwise it will be violation or breach of somebody's privacy. And different algorithms we can use. Average degree of this network, what is average degree? So simply click on this and average degree is 1.127. So if you are working on some research work related to sentiment data analysis, related to social network analysis, these algorithms are available here. Authority distribution, if you want to work on community detection. Okay, edges, unique, we want to find out unique edges, which are the unique edges. So these are highlighted in a particular color. We want to highlight a particular palette. Unique, which are those unique? So we will be able to check it. What is density of this particular network? How many people, how many users are involved in this particular social network? What they are discussing? So we can customize it, and different algorithms are available here. Okay, so in data laboratory we will get complete data in text format, from which Twitter handle, from which hashtag these messages are getting forwarded, and Twitter type, hashtag, or media, it is a media report, or user. If it is a user, there will be hash Twitter handle. If it is a hashtag, it will be a hash with prefix hash. Okay, filtering can be done. Okay, so multiple tools, multiple plugins we can associate plugins on a particular algorithm if you want to work. Okay, so all of these algorithms, if you want to work on DB scan algorithm, on some particular clustering algorithm, minimum spanning tree, we can install it. Okay, diffusion on depending upon particular parameter. Okay, so you can enlarge it. This particular network we can enlarge. So you can see that on mouse over we can see all of its associations. For example, this user is connected to which other users, which user is having maximum strength, maximum connectivity. So on mouse over we can see which person is involved in broadcasting this message or making this message as viral message. Okay, in data laboratory it's text details will be provided. Okay, if you want to generate its graph, if we want to export it, we can export. In which format we want to export it? PDF format. Okay, overview. File to export this data in graph file or any other format we can do. Now you can see that complete network, that social network is exported in this format, in PDF format, which we can put in a research paper, that this type of network we are accessing, we are analyzing. We can export it in graph file also. So in CSV format, and now you can see that it is exported in CSV file format. Okay, and once it is in this format, we can process it in machine learning or AI based models.